Hi, hello, I'm Kiran Kumar from Nature of Physics. Today topic is motion on a horizontal rough surface of a body. Clear with diagram I will explain, student. Please do like and subscribe my channel, student, and comment also. Clearly I will explain, student. Please watch full video, you will get clarity. Okay, student. Now considering there is a block of mass m, student. O is the center of the block, and here a person is applying a force pulling that. Okay, so opposite direction frictional force develop and normal reaction is perpendicular to the surface, and mg is always acting downward direction, student. Okay, so different cases we will have, student. First case one, that is in rest position. The block is in rest position, so here applied force is equal 0. That's why frictional force also 0, student. Without applied force there is no frictional force. And case 2, in the case 2, here the body also rest, but there is a applied force, student. So applied force is less than to the static friction, student. Okay, so the body is still rest only. Okay, and next case 3. For case 1 there is no applied force, here no one is pulling here, and case 2 some applied force is there. That's why I am considering one person is pulling this. One person is pulling this with a force. What is that, student? F less than to Fs. Okay, student. And then case 3. In case 3 also the block is in rest position, but the minimum force applying by 2 persons, student. How many persons are there here? 2 persons are there. 2 persons are pulling this. See, like this I can take for better understanding, taking the diagram, student. 2 persons are pulling, also still rest, student. So that here the applied force that is taken as minimum force, which is F equal to Fs, student, means the minimum force applied, which is equal to static friction. So here both are equal in magnitude and opposite in direction, student. Here applied force is like this and frictional force is like this, student. Both are in opposite direction, so that here also the block is rest only, student. Okay, and case 4, the body ready to slide, student. Nothing but here applied force is maximum. First 0, then minimum, continuously increasing, and finally become maximum, student. In this condition I can write F as static friction maximum. So F force is maximum, nothing but static friction also maximum. The maximum static friction is called, what is that, student? Limiting friction. Fl is the limiting friction, student. See, they are clearly given. So applied force is maximum, that is static friction also become maximum. Already I said you, frictional force is a self-adjusting force, student. Whenever applied force is increasing, then frictional force also increases, student. So the body is ready to move by 3%, student. How many persons? With 3% the body is ready to move, like this taken. Okay, so that limiting friction is there, student. So that F maximum, which is equal to, we can write Fl. Fl is the limiting friction. In this situation the body is ready to get motion, okay, on the horizontal surface, student. And next case 5 is there. So here the formula of F max, which is equal to Fl value is mu L into N, student, where N is equal written as mg. Both are equal in magnitude and opposite in direction, student. Normal reaction and weight of the body balanced. Okay, and next case 5 taken, student. Here the body gets slides, so that body get motion, student. The body get, what is that? Motion. So here whenever the force is applying by first person, the time t is equal to initial time t is equal 0 taken, student. Okay, force is gradually increasing, so the body gets slide. At that time is taken as t, student. T greater than to 0, t not equal to 0, student. In this situation, here we can write the body gets motion nothing but there is a acceleration, student. So that m mass, so there is a acceleration by the block. Okay, so that here 4 persons are pulling this. How many persons are pulling? 4 persons are pulling this. That's why the body get motion, student. So that resultant force which is equal to MA, student, resultant force MA which is equal towards resultant force is applied force is there, student, minus opposite direction is kinetic friction is there, because of in the motion we will get the kinetic friction, in the motion we will get the kinetic friction, student. And also acceleration which is equal to F minus Fk divided by m, student. This is I can write as equation number 1, student. Okay, and continuation here, acceleration A is equal to F minus Fk divided by small m we are getting. So resultant force which is equal to towards resultant force, this is the resultant force is along the motion direction, along that direction is applied force is there, and opposite direction what is there, student? Frictional force is there. Okay, and continuation, if optionally considering, student, there, so that applied force, that is F max which is equal to F S max which is equal to F L limiting friction, student. So that I can replace the value here, so that acceleration A is equal to, instead of F I am replacing FL, student, FL minus Fk divided by m, student. Okay, now this is equation number 2, student. But we know Fl is equal, what is the formula, student? Mu L into N, and Fk which is equal to mu K into N, student. And continuation step we can write here, that is A which is equal to mu L minus mu K divided by m into n, student. N value is replacing, so that we will get there acceleration A which is equal to mu L minus mu K into n is equal to mg, student, divided by m. Okay, here no space, please, here writing mg, student. is get cancel, finally we will get there A is equal to mu L minus mu K into G. This is I can write as equation number 3, student. See, clearly given. Okay, so get cancel, here I wrote n is equal to mg replaced there, student. N is equal to mg is replaced. Okay, now this is the arrow mark. Okay, so continuation next. In the case 6, the body is in motion, that is if the block is in sliding, student, in the sliding, so we are getting kinetic friction, student, and also here resultant force m mass moving with an acceleration which is equal towards the resultant force is F, and away from the resultant force is kinetic friction is there, student. So that A is equal to F minus Fk divided by m, student. So A which is equal to F by m minus mu K into n divided by m, student. But n is equal to how much, student, there? mg, replacing in the above equation. So I am getting here acceleration F divided by m minus mu K into mg divided by m, student, where mm also get cancelled. So that acceleration is equal force divided by mass, applied force divided by mass minus mu K into G, student. This is I can write as equation number